Good. I'll be quick. Good afternoon, everybody. Welcome to this week's session. So today we're going to continue with financial math. We're going to look at annuities and we'll look at calculating the annuity for the present value and the future value of an annuity. So this will build on from what we have done last week, where we looked at simple interest and compound interest. So by the end of the session, you should know how to do basic calculations when it comes to annuities. What are annuities? Annuities are sequential payments that we pay in an equal interval, which includes, if we unpack the annuity, it will contain the payment, which are the consecutive payments, which repeat one after the other. If it's monthly, it will happen on a monthly basis. If it's quarterly, it will happen on a quarterly basis. Then the term will be for how long you're taking the money or for how long you're saving the money. Then we also have the future value, which will be your accumulated amount, the sum of all payments that you are making, which will be your present value plus your including your interest. And this will be calculated at the end of the term. Then we have the future value or the present value, the present value, which will be all the payments that you are making at the beginning of the term. This means it does not include interest. Just to remind ourselves, the compounding periods are like, we remember we don't include the leap years, so it's 365 for daily, monthly is 12, weekly is 52, quarterly will be 4, and half yearly or annually it will be 2, and yearly it will be 1. Just want to make sure that the recording has started. Okay. When we calculate manually, remember the following. Those who are using the manual calculations, you must always remember to divide your interest by compounding periods, and you must also remember to multiply your period by the compounding periods. So don't ask me what this means. That is just the short version of saying how we calculate the present value of an annuity when we have a payment, that is, we're calculating the annuity, this annuity for the term N at an interest rate I, which in a formula form and visually, we say it is R multiplied by the accumulation factor of 1 plus I to the power of N minus 1 divided by I plus 1 divided by 1 plus I to the power N. And remember, I is divided by the compounding period and N is multiplied by the compounding period. So those who are using financial calculator, to answer the same question, the steps are the same as what we have been doing with compounding interest, where we say we clear your calculator from any stored value, second function CA, then we put in the compounding period, second function P/Y, and you put the value of your compounding period, and then you press the ENT button. Then you press the on and off and say plus or minus if we're calculating the present value. So therefore it means they gave us the payment. So we say plus or minus the value of the payment, and we store that value by pressing the PMT button. To put in the interest, remember now, for those who are using the financial calculator, if the interest is 15%, all what you just do is press 15 and press the I and Y button. You do not divide by 100, you just use the value as you see it. Then we can put in the value of our term, and since the term is going to be multiplied by the compounding period, so we put in the value of that term and we press second function N, which has the P, the multiply P/Y, which will be multiplying by the compounding period. And then we press N again to store the value. So it means in this step, you will press N twice. The first one is to multiply by the compounding period. The second one is to store the value of N. And once you are done, you press the compute, which is the COMP button, and then PV for present value. As you can see, all these steps are the same as what we used when we calculating the compound interest. because with the compound interest, they would have given us the present value and asked us to compute the future value. Where you see PMT, you would have put in what you are given and then compute what you are asked to compute. So the steps are exactly the same. So it should be easy to use. So let's look at an example. So looking at the example, we know that the question says, calculate the present value of 1,600 quarterly payments for 5 years at an interest rate of 20% per year compounded quarterly. Since the question is asking us to calculate the present value, I will look at the formula for the present value, which is P is equals to R times the accumulation factor. So I can start by identifying what I have in the question so that I know exactly what to do. So I'm calculating the present value, which is P, which is what I need to be calculating. I'm given R, which is my payment. I am told 5 years, which is N, 5. My interest is 20%, which is I, and I have to divide this by 100 to get it to a decimal. So that will be 0.20. So since I have all this, I must also remember what my compounding periods are. So that is quarterly, therefore it is equals to 4. In a way, so that you don't have a messy calculation on so many things happening, what I will suggest you do is, before you substitute the values into the formula, especially for the N, for the I, please make sure that you calculate them outside. What I mean by saying that is to say N will be 5 times 4, which will be equals to 20, and I will be 0.2 divided by the compounding period, which will be equals to let's go there, 0.2 divided by 4, which will be 0.05, which is 0.05. Then you can take those values and substitute them into the formula. And the reason for this is just to make sure that your calculations must not create a mess when you are doing all these calculations in one, because you're going to have so many fractions that you're working with and so many powers, as you can see there. So I have replaced I with 0.20 divided by 4 because I need to remember that I is divided by the compounding period and N is multiplied by the compounding period. Otherwise, if I would have calculated everything outside of the formula and just come and substitute, the formula becomes easy because my I is 0.05 and my N is 20. So I just substitute where I see I as 0.05 and where I see N as 20, and it looks neater and easier to read. Then you just calculate what you need to be calculating. So if I solve all this, everything in the bracket multiply by 1,600, the answer I get is 19,939 Rand 35 cents. Any question? If there are no questions, then we move on to how we calculate this on a calculator. So also the same question, we can use our financial calculators. So we also need to state what we are given in terms of the things that we see in front of us on the calculator. We know that we're calculating the present value, which is PV. So at the end, we will need to COMP PV. We need our payment. This is PMT on your calculator, is the button PMT. N is our 5 years. And I/Y is 20. And P/Y, which is compounding period. There are 4 compounding periods. So the first step, easy one. Clear your calculator from any stored value. And then put in your compounding period by pressing second functions PY, 4, E, and T. And when you are done doing that, you press the on and off button. Now we're ready to capture the values we are given. We are told what the payment is, so we can start with the payment. Remember here also, the order does not matter. You can start with the interest, then move on into with the payment, or you can start with the period and then go and enter the payment and then enter the interest. It doesn't matter the order for the next three things that you need to capture. So the first one, I always start with the payment or whatever the bigger value is, which is the plus or minus 1,600, which is my payment, which is PMT. And then you press the year. I'll do the year in that sequence. So year is 5 years. I need to multiply by the compounding period. So I'll press second function N and then N again. So the P/Y, it's on the button N. So that is why I'm saying you press N and N again. So you press N twice. Then I can put in my interest rate, which is 20%, and compute my present value. And when I press COMP, the answer I get will be 19,939.54. And that is how you calculate annuities. With that, I have an exercise for you to do. What is the present value of an annuity of 1,500 at the end of 6 months period for 2 years if the money is worth 8% and it is compounded semi-annually? You need to identify what you are given. Those who are calculating manually, I'm going to split the screen in two. And those who are calculating manually, you need to identify what your payment is, your interest is, and your N is. You need to also identify your compounding periods, which are those, your compounding period. And then once you are done, then you can substitute. You know, we're looking for the present value, which is P, and the formula is R times 1 plus I to the power N minus 1 divided by I times 1 plus I to the power N. That is for those who are calculating manually. Remember, your I, you need to divide by the compounding period. So N, you need to multiply by the compounding period, and then you come in and substitute. Those who are calculating financial calculator, the second function, CA. Oh, sorry. Also, identify what you are given. My bad. Identify what your PMT is. Identify what your interest is. Identify what your N is, and identify what your compounding periods are. And once you have all those, steps are easy. Second function, CA. Second function, P/Y, and you put in the value you have identified for the PY, and then you press ENT. Then you go on and off your calculator. Then you press plus or minus. And since we know that we are given the payment, you go into the value of your payment and press PMT. Then you press the value of your interest and press I/Y and the value of your period. And since we're going to multiply by the compounding period, second function N, and then N again, and then comp present value. Okay. I see here someone already calculated. Okay, and someone already liked it. Okay. You still busy calculating? Okay, let's help those who don't know or are lost. I'm going to change the color of my pen. Okay, I'll start with the manual calculations one. So our payment is 1,500. Our interest is 8%, so it will be 0.08 divide our compounding periods. If I start there as well, there are 2. So it will be divided by 2. Therefore, this will be 0.04. Our period, it's for 2 years. So we need to multiply by 2, which is equals to 4. Then we can substitute into the formula. Our payment, which is 1,500, multiply by, into bracket, 1 plus our interest, 0.04 to the power 4 minus 1, divide everything by 0.04 times 1 plus 0.04 to the power 4, and close bracket. And that will give us, if we calculate all of this, by solving what is inside the bracket, taking the power, minus 1 divided by 0.04 times 1 plus 0.04 to the power of 4. The answer we get will be 544.84. Those who are calculating manually or using a financial calculator, your payment will be 1,500. Your interest is 8%. Your N is 2 years. Your compounding period is 2. Second function CEA, second function PY, 2 years, 2 semi-annually for our compounding period, ENT, on and off our calculator, plus or minus 1,500. Our I, which is our interest, is 8. Our N is 2. Second function, N again comp, you'll get the answer will be the same, 544.84. And that's how you calculate the present value of an annuity. Now let's look at calculating the future value of an annuity, unless if there is someone who has a question. If there are no questions, you can check also on the chat. Nothing. Okay, move on.
No, sorry, ma'am. Can I ask something regarding the semi-annually? What does it mean when you say semi-annually? Why are we multiplying our N. Yes, why are we multiplying it with 2?
So remember the compounding periods?
Yes.
6 months. It's how you split your year. If you split in your year in 6 months, so therefore there will be 2 parts in the year, because 1 year will in a year, the 6 months will have 6 months, will form one part, and then the other 6 months will form another part. That's how we split the year to find the compounding periods. And remember, it can be called biannually as well, or it can be called half yearly as well. And then now we learned that it's also called semi. So maybe I must add onto here / semi-annually as well. So as long as they tell you that it's compounded semi-annually, you need to know that there will be only 2 compounding periods, because semi-annually it will be 2 half of the year. The same way as if they ask you monthly, there are 12 months, so there will be 12 compounding periods. Okay. Reason why we're dividing and multiplying by 2 of semi-annually, so I need to quickly go back to there, is because our interest, we have to divide by the compounding periods. So our semi-annually are equals to 2. And the reason why I also know that it's semi-annually will be equals to 2 as well. So you can also pick up some of the things from the content that they give you. They say it will be paid up each 6 months. So it means the first 6 months and then the second 6 months. So it's semi-annually. Or they could have used the word biannually. Okay, so we divide by the compounding periods and we multiply by the compounding periods. Do you understand? Or you still lost?
Yes, I do. No, I understand. Thank you so much.
Thank you very much. Okay, so let's look at the future value of an annuity. So when we calculate the future value of an annuity, now we want to find out what will be the accumulated amount after you made all the payments. And all these payments includes interest. So we want to know at the end of the period how much you will have, and that is the future value. And to calculate that, we use the formula S is equals to R times 1 plus I to the power N minus 1 divided by I, where R is your payment, I is your interest, N is your period. And remember, you remember to divide your interest by the compounding period and to multiply your periods by the compounding periods. Okay. Those who are calculating using the financial calculator, same. You will say second function C8, get your calculator from any stored value. Then you will put in your compounding periods. Then you will go on and off your calculator. Then you do the plus or minus and put in your payments. And then move on into your interest. Then move on into your term and add, divide, multiply your period by the compounding periods by pressing N and pressing N twice. And then compute your future value. Let's look at the example. Jack will need 20,000 to buy his brother's car in 2 years' time. So we know that in 2 years' time, he needs that. So that is the money that he will need in 2 years' time. That is the future value money that he will need. He wants to start saving part of his weekly salary into this account to return 8.5 interest per year, compounded weekly. So we know what our compounding periods will be. calculate the minimum weekly salary, weekly payment that he needs to make in order to have enough money into this account. We want to be calculating the future value of this annuity. We are given the future value because the future value is the amount that they need to be paying. So, based on the question, our S is 20,000. Our interest, which is I, we will need to say it is 8.5 divided by 100, which will be 0.085. Compounded weekly, so our compounding periods is weekly, so therefore it will be 52. Then it means our interest we have to multiply by 52. We'll have to multiply our interest by 52. For how long? We know that we need 2 years. That is how long. So our N, we could have picked up N as well there. So our N is 2 years, and we'll have to multiply these 2 years by 52 as well. Then once we have done that, we can come and substitute into the formula. So substituting into the formula, I said multiply interest. This should be divide interest by 52. Then we calculate the formula, and what we end up with, it will be R times 113.23469 is equals to 20,000. That's what we will have on the other side. After we have solved what is inside the bracket, and once we've done that, then we can just divide, move the 113 divided by 20,000 divided by 113, and we'll get the answer of 176 Rand 58. So he needs to make 176 Rand 58 cent payment into the investment account. Calculating on a financial calculator. We also need to identify what we're given. This is our future value. We know our N. We know our PY/Y. We know our interest. And then we can substitute into the formula. The first part, the calculator from any stored value. Then second function P/Y 52 ENT, that's entering or capturing your compounding period. Then we go on and off our calculator, put in the future value, which is 20,000, will be plus or minus 20,000 future value. Put in our interest, which was 8.5. And that is our I and Y, and then we put in the period, which was 2 times second function N again. So we multiply it with the compounding period. And when we compute payment, the answer we will get will be 176 Rand 58 cents. Any question? Okay, if there are no questions, then here is our exercise. Similar. You will need to be to find out what you are given. So just to make sure that you know what you are doing. So Sarah will need 100,000. That's the question. Sarah will need 100,000. So that already is our future value, which is our S, or our future value, depending on which steps you are using. And she wants to deposit 500 per week. And this is our R, or PMT, into this account, which offers interest of 9%. So this is I, or this is also I/Y. I'm going to put it that way twice because I want to also say this is 0.09 for those who are calculating manually. And it is compounded weekly. So our compounding periods are 52 because it's weekly. What they're asking you to calculate is N. And the other problem you will have now is the answer here is not in a weekly position, so it is N. The answer you get, you will always have to divide by the compounding period. Those who are calculating using financial calculator, the steps are easy. Second function CA, second function P/Y, and then you will need to put in the value and then press ENT. You go on and off your calculator, plus or minus. Since you are given the future value and the payment, one of them can have a plus or minus in front. You can choose which one. I'm going to choose it for you. So we're going to put the plus or minus in front of the 100,000. So we're going to say plus or minus 100,000, which this becomes our future value. And then you're going to press the value of your PMT. Or you can use PMT as plus or minus. It doesn't matter which one you start with. And then we are also given interest, which is I/Y. And then we comp N. And once you get the value of N, divide by the compounding period. Those who are calculating manually, we need S is equals to your R times 1 plus I to the power N minus 1 divide by I. All what they want, make N. So you can do that if you solve the equation step by step. So you will need to know how to use the log. I guess those who are using the financial calculator, it will be easy for you to find the answer quick. So you saying it is option 3. So you calculated it. So let's see if you put in the right values. Our compounding periods, there are 52. Our future value is 100,000. Our payment is 500 per week. Our interest is 9. And when you comp the values, and I can quickly check for you as well. Second function CA, second function INY, 52 ENT, on and off your calculator, plus or minus 100,000. That is our future value. And 9 is our interest. And for how long is what we want to be calculating. The other thing we are given is the payment of 500, which is our payment comp N. And the answer you get for N will be 171.8939 divided by the compounding periods, which are 52. So if I divide by 52, I get 3.3. That is the answer you will get. Those who are calculating manually, I'm going to substitute 100,000 equals, our R is 500 times 1 plus, that's the other thing. I need to find the value for I, which is 0.09 divided by 52 gives me 0.09 divided by 52, 0, so I'm just gonna substitute it right here, 0.0. Since my calculator is in 4 decimals, I'm just only going to keep the 4 decimals, 0.017. And this is to the power of, I must also do the same. My N, I don't know how much is my N. So that's what I must calculate, minus 1 divide by 0.0017. So now, since I'm doing this manually, I can solve what is inside the brackets first, because I need to do it step by step so that I make sure that I get all the values right. So I'll keep the 100,000 outside, and I'll keep the 500. Then I will solve what is inside the bracket, which will be 1.0017. And since this is to the power N, minus 1 divide by 0.0017. Now, here is the challenge with this. Since I am having a multiplication of whatever is inside the bracket, the other alternative is also to remove the 500 first. So I can divide this side by a 500. So when I divide this side by 500, it means the 500 this side divide, and I must divide this side by 500. So then the answer this side, the 500 here will cancel out with that 500. And then I will be left with 100,000 divided by 500 gives me 200,000. 200. 200. Did I divide correctly? 100,000 is 200. And everything else that is inside the bracket, I can remove the brackets for now. So since I'm running out of space, I'm going to remove some of the things that are here. So I'm going to be left with what is inside the bracket, which, no, I don't even have to write the bracket anymore because I'm not multiplying. I'm having 1.0017 to the power of N minus 1 divide by 0.0017. So now The other thing, I can multiply this side by 0,0017, and I must also do the same, 0,0017 this side. So it means this will cancel out, and 0,200 multiplied by 0,0017 gives me 0,34. So this side I will have 0,34 is equals to, and this side I will be left with 1,0017 to the power n minus 1. And what I can do as well is to move minus 1 to the other side as well. So I can just subtract by 1, and this side I will be left with 1,0017 to the power n, and 1 minus, this is a mission and a half to do this whole calculation. So 0.34 minus 1, I get minus 0,366 minus 0,66 equals, and then this side I have, I will have this side 1,0017 to the power n. I'm going to remove everything that we did here because you already have this, so that I can have enough space. Okay, so now, before I solve everything, I want to move that last line, minus 0,66 is equals to 1,0017 to the power n here. And I want to apply the log. Remember, the logarithm said if I have x to the power 1, y, I can write, if I need to apply the log of x to the power 1, it will be the same as y times the log of x, law of logarithm. So if I apply the log of minus 0,66 is equals to the log of 1,0017 to the power n, I can rewrite this as n times the log of 1,0017, and this side will be the log of minus 0,66. And it means I must divide both sides by the log. So this side will be n divided by the log of minus 0,66 divided by the log of 1,0017. And calculating that, finding the log. I need to find another calculator. Let me see you on the, okay, log is on button number 1 on the financial calculator. So this will be second function button 1 and minus 0.66 close bracket divide by second function 1,0017 close bracket and oh, sorry, we don't have to, sorry, my bad. This side is subtracting. When it comes this side, it's adding. Sorry, my bad. This is very wrong. Sorry. This will be 1,34. Sorry, it's not minus, it's 1,34. Sorry, my bad. I need to fix this. The whole of it. So this is 1,34. This is 1,34. This is 1,34. 1,34. So we need to say second function log of 1,34, close bracket, divide by second function, the log of 1,3 of 1,0017, close bracket, equals, and I get 172 point, so I'm getting more. The answer is 172.30, and I need to divide this by 52. And when I divide that by 52, I get 3.3. And you get the same answer as that. So it takes longer when you don't have a financial calculator. And that is what is going to happen also in the exam. You will take twice or longer time to solve some of the questions because you don't have a financial calculator. You have to calculate things manually. Okay. And that concludes the annuities. If you have any question, now is that chance to ask. Let's see, I see some chat. Krista, there is a link. I'm going to copy the link again. Please make sure that you complete the register. I'll paste the register on the link. Make sure that for the tutorials, we always have the link to. The only problem is with the Akalit. Please make sure that you complete that register. The link is in the chat. Okay, so.
Thank you, I'll have a look at it.
Thank you. Let's do more exercises. I think I have 3 exercises and then we call it the quiz for today. Then you can go enjoy your Saturday. Joseph bought a townhouse in North Riding for 700,000. He paid a deposit of 100,000 and managed to secure a loan for the outstanding amount. Now, remember, he paid a deposit. The house cost 700,000. He's only going to finance the balance after the deposit. So you need to subtract the deposit and use the balance. The term of his loan is 20 years and the interest is at 7.75 and it's compounded monthly. Calculate Joseph's monthly payment. And the other thing to always remember is loans are always present value because the bank will give you the money you need to pay an X amount. And at the end of the term of your loan, you would have contributed the future value because it will have the present value of the loan that they give you plus the interest that you pay. So it means loans will be present value. Savings, because when you save, you don't know what the future value is. Yes. Question?
Sorry, ma'am, Lizzie.
Yes. Oh, I thought you have a question. Okay, so loans, it's always present value, but the accumulation or accumulated value of that loan is a future value. Savings, it's always going to be a future value. Okay, so with that, you can now try and answer this question. So those who are calculating manually, the formula is because we're having a present value. So this will be P is equal to your R times your 1 plus your I, since this is a loan, minus 1 divided by I times I to the power N. And those who are calculating using steps, but you know that before you do this, you must state what you are given. So I'm just giving you the formulas. Second function CA, second function T/Y, EMT, on and off your calculator. present. There is something that is missing, and that thing that is missing is the plus or minus. And remember, you want to calculate the payment. That's what you need to be calculating. PMT, R, payment. Okay, I guess those who are using financial calculators, it's easy to find the values quick. So let's see. We are given 700. So to calculate our P, which is our present value, we'll say 700,000 minus the deposit of 100,000, and that will give us 600,000 as our present value. And our N is 20 years. Our interest is 7.5, so it means our I is 0.0775. Our N is 20. How much is compounded monthly? So this will be 20 times 12, and this will be 0.07 times divided by 12. Calculating that, when 0.0775 divided by 12 gives us 0.065. Let's keep it to, yeah, we can leave it at 4 decimals, it's fine. So our I will be 0.0065. Our N, which is 20 times 12, is 240. 240. So we come here and we substitute. We have 600,000, which is our present value, and we need to be calculating R, and then we substitute the values, which will be 1 plus 0.0065 to the power 240 minus 1 divide by 0.0065 times 1 plus 0.0065 to the power 240. And once you get the answer, will be R will be equals to, I don't know what R will be. Those who are calculating manually using the financial calculator, based on the information we just used, compounding periods, there are 12. This is 600,000. Our interest is 7.75. Our term is 20. So if I use the calculator, second function CA, second function I and Y, 12, E and T on and off your calculator, plus or minus 600,000. That is our present value. 7.75, that is our interest, and 20 years, second function, N again is 240, that's my period, and compute your PMT, which is 4925. So therefore it means here you will get 4925.69. And that's the same for everybody. Any question? If there are no questions, then we move on to the next exercise. Also, this is a present value calculation. So, because it's a loan, so it will be P is equals to your R times, I am going to just do it automatically because we need to just divide by the accumulation factor. So we need to calculate R. So R is equals to P divided by everything inside the bracket. 1 plus I to the power N minus 1 divided by I times 1 plus I to the power N. Those who calculating using the financial calculator, you also need to know the steps. By now, I shouldn't be writing all the steps for you. You should know them by heart and be doing them without even blink of an eye. Because all they want is the monthly payment, which is PMT. Okay, I can see you saying it's option 2. Okay, let's see if it's option 2. So those who are calculating manually, you will have to calculate it and tell me. Those who are calculating using the financial calculator, the compounding periods, there are 12. Present value is 80,000. Our interest is 10.5. Our periods, for how long? For 5 years. So that is 5 years. And then you compute payment, and that will give you option number 2, which will be 1,719.5120, which we rounded off to 2 decimals because it's money. And those calculating manually, that will be 80,000 divided by everything underneath the bracket, which will be 1 plus, we need to go and do this manually. Outside, I is equals to 0.105 divided by 12. 0.105 divided by 12 gives you 0.0088, which is 0.0088. Then we also do the same with 5 years. N is equals to 5 times 12, which will give us 12 times 5 gives us 60. Therefore, this is to the power of 60 minus 1 divided by 0.0088 times 1 plus 0.0088 to the power 60. And when you calculate all this, you should get 1719.51. And I think this should have been your last question. So some of the questions looks like this. So I'm not going to ask you to do all of them. We will do the last question. Let me see. Not that one. So let's use this one as our last question, and then we conclude today's session. How much to the nearest rent can Lerato borrow from the bank if she can repay the loan by means of quarterly payments of 2,000, starting at the end of the first quarter? Actually, I'm looking for the one that it will be their future value. So how much in the nearest rent can Lerato borrow from the loan? And it will be, because she's borrowing, it will be present value. Peter borrows 500,000. Okay, also this one, it is, okay. All right, let's do this one, because then this gives us another chance to discuss how we will calculate the periods. Peter borrows 500,000 from the bank and he will repay the loan by means of monthly payments of 8,000 starting at the end of the first month. Interest is charged at 18%, compounded monthly. Determine how many payments of 8,000 will he have to make. Now, with this question, they want to know how many payments, how many of those payments, your N in number of months, because this is compounded monthly. So you will say second function CA, second function P/Y, and you will put the compounding periods and press the E and T button. Then you will go on and off your calculator. And then you will go and say plus or minus. We can start this one with the payment. So you can put there the 8,000. You can use the payment. So this will be PMT, and then you will have your present value, which is 500,000. Our compounding periods were monthly, so it will be 12. Then you will do your interest, which is 18. And this is I/Y. And then you will comp N, and the answer you get, that will be the answer you get. On the other hand, to calculate the N, remember, which is R times 1 plus I to the power N minus 1 divided by 5 times 1 plus I to the power N. Now, here is your challenge. You have two N's on this one. The other one was easy because you only had one N. You had one N. Now you have two N's. You will need to know how to make sure that you only get N, only one N at the end. So you must solve for N. So you can go and do that to give you the answer for the question. Since I've already gave those who are calculating manually, I can do that for you as well. Second function CA, second function I and Y, which is compounding periods. There are 12 months, E and T on and off. Plus or minus 8,000. This is our PMT. The other one is 500,000. And this is our present value. Our interest, 18 is I and Y. And comp N, and my comp N is equals to 1. That is the answer. Because they want to know how many number of payments, which means the number of payments will be compounded monthly. So there will be how many number of months that he has to pay all this. There will be 186 months that he has to settle this loan of 500,000. So to make N the subject of the formula here, it's going to be a little bit tricky, but it's doable. Let me show you the easy way. I'm not going to finish it all up. I'm just giving you the easy way. So we know that R is multiplying everything in the bracket. So if we start by dividing P by R, so we already solved one of the problem, because divide the side by R will cancel out, and R will divide P by. Now we need to remove the bracket. And then we go on and we remove the bracket. So we remove the bracket. And once we have removed the brackets, the other thing that is remaining is getting rid of all this that is inside the underneath. The alternative one is to multiply throughout inside the bracket with an I. So that will multiply this, we'll have an I plus I squared, which will be equals to the power of n. That's what we will have right here at the bottom. At the bottom, or alternatively, what we can do is take whatever is at the bottom and multiply with what is at the top, which is I times 1 plus I to the power of n divided by r. Alternatively, you get all the values in. It's easier when you're working with the values. So then it means you're getting 1 plus I to the power n minus 1. There is some thingy at the end of the channel and at the end of the road here. So since we have all this, then we can subtract 1 from this. So therefore it means we can also, instead of saying minus 1 here, we can take minus 1 and add it to this side and say equals to this. So by taking that minus 1 and adding it to the fraction, then we have plus 1, we are left with only those two things. So to get rid of those, substitute all the values. It's easy when you have the values, not the i's, at the actual value. So it means you will go and say 0.18 divided by 12. We left with 2 minutes, so it will be 0.18 divided by 12, which is 0.15. You will substitute 0.15 there, 0.15 there, 0.15 there, which will make it easy because you can multiply throughout the bracket with this, and then you also multiply throughout the bracket by P and R, and then you will have only the values inside the bracket with to the power of n, and then you can apply the log. So n will multiply and n will multiply the side, and you will just need to make sure that you get both of them on one side so that then you can answer the question. So, but you will have to solve the equation like that. So up to you how you want to do it. You can start first by substituting all your values into your formula. Because if you try to make n the subject of the formula from this complex formula, it might take you forever. R times 1 plus I to the power n minus 1 divided by I times 1 plus I to the power n. Substitute the values and make sure that you make n the subject of the formula. It's easy, it is doable. You just need to make sure that you use the right value. So remember, this will be your I, which is 0.015. And you calculate your n, which will be how long is what we're looking for. Okay, and that will conclude today's session. So if I can recap on what we did today, we looked at how we calculate the basic annuities, and then we looked at how we calculate the future value and the present value of an annuity. Remember, those who are using the financial calculator, the steps are always the same. And those who are calculating manually, remember to always divide your compounding periods by your interest rate by the compounding period, and to multiply your term by the compounding period. And with that, it concludes today's session. Thank you for joining and thank you for coming through. Enjoy the rest of the weekend. I will see you next week, Saturday. Remember, think about what question paper we want to discuss in the next 2 weeks that are coming. And also the last Saturday we will be doing amortization on Friday, if you don't want to attend the Saturday, but it's very important that you come on Saturday, then on Friday, this coming Friday, we will also be doing amortization. So you can come twice so that if you didn't understand on Friday, you can also understand on Saturday. So the next coming Friday, we'll do amortization. And also on Saturday, as part of your tutorial session, we will cover the amortization. See you Saturday next week or Friday, whichever one you feel like attending. Thank you guys for coming through and enjoy the rest of the weekend.
Thank you, Liz.
Thank you.